and welcome to the first edition of our new podcast series, Inside Siemens, Business is Shaping Our Future. I'm Eva Riesenhuber, Head of Investor Relations at Siemens, and my guest here today is Sabine Erlinghagen, CEO of our Grid Software business within Smart Infrastructure. Sabine has more than 14 years of experience in smart grid and energy software, and she's now taking the Siemens Grid Software business to the next level. Sabine, thank you for joining us today.
Thank you, Eva, for having me in this first edition of this podcast series.
Great. So let's give our listeners, our analysts and investors some orientation of where your business actually fits within SI, within Siemens.
Sure. We are a team of 2,500 in our grid software business, and we combine OT domain expertise, that means how grids actually work, and IT and software competence of our developers and across the board. And from a Siemens perspective, within SI, we are a key contributor to achieving our target of 1.5 billion euros in digital revenue by 2025.
That's very exciting. This IT-OT combination is obviously one of your unique selling propositions, and we get back to that. But let's just give the big picture, because this is also a fantastic example of technology with purpose. Because what we're really talking about today is a transition to net zero. These grids, they have been around for decades. So for 100 years, we actually have been building grids, and now they have to become so much smarter, so much more nimble and flexible, and deal with power inflow and power outflow, multidirectional, all of that at the same time. While if we actually really honest, the way that grids have been run has not really changed over the last 100 years. So Sabine, maybe you can give us some insights here, because now the war in Europe is rapidly accelerating the energy transition towards the reliable and sustainable grids for an affordable energy supply. And what does that actually mean for Siemens Grid Software? What role do you play in empowering our customers for the energy transition?
Absolutely. I think you said it rightly. The grid, and essentially and how it has been running, has not changed over 100 years. So we still run the grids roughly with the same methods than a long time ago. Now, the increasing complexity that we see that comes into the grid with distributed energy resources is putting that to an end. We need to rethink grid management. The complexity has increased already, but it will increase exponentially from here. And that is because we are connecting 7x the DERs, the distributed energy resources, that is solar, that is battery storage, that is electrical vehicles, that is wind. And software is the true game changer here. Software enables us to increase that DER hosting capacity and cope with the intermittent and unpredictable power flows that you have been describing.
That's really interesting, but since we have to quantify it for our listeners to put it in perspective, what market size are we actually talking about?
We're talking about a 10 billion market, 10 billion euro in size for grid software. And that market is growing to 17 billion only by 2028. The market that I'm describing here ranges from advanced grid management software to network planning to grid and customer analytics.
And what's the position of your business in that market?
We proudly consider ourselves to be the market leader. One stat that I particularly like is 70% of the world's electricity consumption runs through grids that have been planned and modeled with our software. We have an installed base of 1,300 control centers around the world, which translates into we help keeping the lights on for hundreds of millions of people. And finally, if you think about our smart meter business, actually the smart meter software business, we help connect and manage the data for 100 million smart meters in over 200 utilities worldwide.
Wow, these are really impressive installed base numbers that you can already build on. It shows a long history and the organic growth that Siemens has already in this area. Now it's being taken to the next level. So going a level deeper, what is the true game changer for our customers? And if we look at that, it seems to be the distributed energy resources. Why are they so relevant in the grid software market?
They're the pivotal thing. because we see a 7x growth. That is exponential growth until 2030. So that is 8 years from now. And the dynamics is really exponential here. And it's adding complexity at that exponential pace. Before we had large power plants, few of them. Now we have millions. We have 5 million distributed energy resources added per year in 2020, and we go up to 35 million in 2030. So it's the speed and the scale of this change that is unprecedented and really tells us the time to act is now.
So who are the customers of your businesses, the one that have to act now? Could you give us some more specifics, please?
Sure. First group is transmission system operators. That's the high voltage level. They have been operating and maintaining the grid stability for us over the last 100 years. And the second group is distribution system operators. That's the medium and low voltage levels of the grid. And it's especially the DSOs that encounter those tremendous challenges of DERs that I've been talking about. And if you think about transmission system operators, we talk about a few hundred. Distribution system operators, there we talk much higher numbers. It's 10,000s of grid operators around the world.
So let's take them one by one. Let's start with the transmission system operators, the ones with the high voltage grids.
Sure. Transmission system operators are already highly automated today. They have a lot of measurement points on those big high voltage lines out there already, and they measure that on a millisecond basis. Now, they've been coping with a relatively high share of renewables already. If you think about the stats, we come to 30-50% of renewables, but they're coming to a limit. If there are too many renewables in the network, then the whole network loses its stabilities, it loses the inertia, and it cannot keep its frequency. So the risk is really blackouts here. There was a recent article in The Economist that really well described that phenomenon and the risk of getting to this tipping point of not being able to cope with the loss of inertia.
Oh, hang on a second here. To get to net zero, I thought we're talking about 100% renewables and connecting them to the grids. Is that then even possible?
Gladly it is. Let's take the island of Hawaii as an example. On Hawaii, we already have 100% renewable supply, at least at certain times, because they have a lot of hydro, geothermal, biomass, and so forth. And there we could prove that you can actually run a grid over a longer period of time on a 100% renewable basis. And we do that by integrating dynamically the simulations and therefore adjusting dynamically how the grids are run.
That's really comforting to know that software has the answer here. But now let's go to our distribution system operators. You said they actually have an even bigger challenge.
That is so true. So far, distribution system operators have not taken part in stabilizing the grid. And also they have had the challenge to onboard all those distributed energy resources. Now, if distributed energy resource connections go up exponentially, that of course makes the life of a distribution system operator much more complicated, onboarding all of them, keeping track and managing that proactively. Now, with the challenges that we've just seen on the transmission side, it's actually the distribution system operators that need to help out. They need to take their part in helping stabilize the grid, so their role will be totally changing. And this is particularly challenging because they don't have the transparency, they don't have the automation. For the lowest voltage level, we can basically say the lights are dark. They have no transparency on what's going on there. So there we have to really invent truly disruptive and new methods to get that done, manage lower voltage levels and keep the stability in our grids with very new methods.
This sounds like a huge challenge. So how do they actually deal with that? Does that mean more hardware? Does it mean more software? What is the solution to the problem?
Yeah, that's actually a very, very interesting question because essentially those DSOs need to avoid becoming the bottlenecks of the energy transition. And with more hardware invest, which of course is necessary, you need more automation, you need copper for extending the lines. But this is very slow and also extremely expensive to do if you would do that the same way and the same recipes you have done it in the higher voltage levels. So software is really the game changer to make that affordable. And essentially we're talking about running the grids closer to their limits. So if you have the transparency of how a transformer is run, if you have the transparency of how the grid is behaving every second, then you can run them closer to the limits and you can be much faster. So there is this paradigm shift, and we believe software is the success factor in there.
You explained to me at the beginning that really the way that operations are being run hasn't changed significantly over the last decades. Now you're pointing that it has to be completely different. And this actually brings me back to the USP that we talked about at the very beginning, the combination of IT and OT. And maybe you can just give us a little bit more insights. How does that actually work?
On our Grid Software Summit on May 5, we have basically presented that we fundamentally need to rethink grid management. And with that, rethink grid software. We believe we need to cut down the silos, and that's not only us, it's also the distribution system operators and how they operate. There's a different department for planning a grid, operating a grid, collecting smart meter data, and there's different software for each of those different departments. And there's a big divide between IT and OT, both organizationally, but also from a technology standpoint. And if you want to gain the amount of efficiency that we need here, if you want to gain the amount of transparency that we're talking about to deal with this complexity, you got to brutally think that differently. And that means integrating between plan, operate, and maintain, both on a process level, but also on a tooling level, and really think the applications. And that leads to a really interconnected and truly integrated, actually, IT and OT landscape, which is a groundbreaking change for those DSOs.
So when you talk about combining all of those different aspects, what exactly does Siemens Grid Software offer for your customers that make the true difference? Maybe you can elaborate a little bit on your portfolio.
Sure. I've been saying it's about integrating planning, operations, and maintenance. And we actually play in all three areas. Planning, it's about simulation software, it's modeling, and the grid model, so the digital representation of the physical grid. And that rings a bell in the Siemens context. We talk about digital twins. We talk about the control, so the operations of the network. That's the kind of keeping the light on every minute, every second. And then we talk about the IoT backbone. So Gartner just said that metadata management, and we are the market leader in metadata management, is the richest source of IoT data in the grid. And finally, of course, you scale that down to microgrids, to EV charging, so to take the grids to even more micro and decentralized layers.
Okay, so I want to get back to so many different things you just said, the digital twin, the metadata system, like these are all super exciting topics, but you also said something else. You referred to May 5. So you just had an event on May 5, and it really is another step. It's where you basically said we're taking it to the next level, even though you're market leader. So maybe you can explain what that means.
Very true. I mean, we're not leaning back on our market leading position, but basically decided to reinvent ourselves at the same time. So we simply have done the math, and we believe that what's out there in the market is just not good enough. So we've been presenting to our customers and to our dear partners how we rethink grid management and rethink grid software, and basically shared our vision to autonomous grid management. And autonomous grid management, you can think that a little bit like autonomous driving. So you get from assisted driving, that's where we're going now, then to truly autonomous management of the complexity in the grids.
So you're now reinventing yourself. So we just learned you're breaking down silos between traditionally very, very separate ways of dealing with the grid. Now you're reinventing that and taking it to the next level. Give us more details. Help us out here.
Sure. So let me take the example of metadata management, because that has been around for quite some time, but the role it now takes in grid management is fundamentally different. So we just redesigned the complete UX of our metadata management software, and we've taken it to a cloud-native solution. So Silicon Valley Power in Santa Clara, California, is just transitioning to that MDM, metadata management as a service, and they do that really to reduce their total cost of ownership and to focus on their core tasks and take advantage of a really nimble solution that can adapt fast, that can update fast, and so forth. So that's just one proof point to show what we mean with reinventing ourselves. And that's just one example. We did the same for our grid simulation software, taking that to the clouds. We're operating with open APIs. We increased the simulation speed 6 times by redesigning and taking it to the cloud, which of course is a great advantage to simulate faster and bring simulation closer to the real-time operation. The underlying principle of that reinvention, if you want, is very coherent design principles for our software. Let me just highlight a couple of them. Interoperability and modularity are really key. They enable grid operators to react much, much faster to the uncertain future that is ahead of them and allows them really to think and support their processes end to end. Then openness is another of those design principles which is key. It's about open industry standards, open interfaces, and it allows our customers to easily extend their applications without making compromises on upgradability, cybersecurity, and so forth.
I love those design principles of interoperability, modularity, and openness because you find them across all of Siemens software offerings. It's really something that is significant and it represents how Siemens approaches software, making it easy for our customers. Now, brings me to another one that we obviously, our listeners know from DI software and other areas of Siemens. It's a digital twin approach. So what does a digital twin mean in the context of grids?
I've already been talking about how we take the representation of the physical world, the network model, to the digital world. And before I talked about the silos, there are network models in planning, there are network models in operations, there are network models in maintenance. And now we actually synchronize that, and that has huge benefits. The example I want to give here is American Electric Power, and we are a proud partner of American Electric Power to do exactly that. So with a centralized approach to network model management, to digital twin if you want, they actually use the same virtual representation of the grid in all of their processes. This not only reduces manual tasks, but it gives them that true image of their network in all their different departments. That's what I meant with cutting down silos. And it enables them to do proper data management, proper data analytics. And really, it very much is like what we do in the industrial space, as you said.
And I also promised you I get back to another point that you mentioned. You referred to Gartner and that they consider meter data to be the richest source of IoT data in the grid. Now, you said you agreed, but what does that mean?
Thanks for getting back to this, because I was getting so excited about our new UX and about our cloud version, but there's so much more to it. Traditionally, meter data was really only used for billing purposes, so knowing what the consumption is and then issuing the correct bill. But now we use meter data also for our simulation software. And let me just put that into perspective for you. When you have grids, operators have transport losses, and they don't know exactly where and why. If you use meter data for simulation, you can actually identify those transport losses and stop them. So to put that into numbers for everyone, if we only save with that exercise 0.1% of losses in the EU, this is equivalent to one mid-sized power plant that we can save. And if we are around 8 to 12% of such transport losses, then imagine we go to 1% of savings and understand the reasons for that. So we could shut down 10 medium-sized power plants. So that's just one example how meter data is getting so rich. And the other example, which I'm very excited about, is how we use meter data then to switch the lights on and get the transparency in the low voltage grid. You remember I talked about those distributed energy resources, and they're coming in really at that low voltage grid. So in the households, in the car parks, and so forth. Distribution system operators have no visibility in that network. It's literally dark. Using meter data management or meter data, you can actually use the digital twin approach and switch the lights on. You can make that grid transparent and help manage that closer to the limits. And here we actually use artificial intelligence to do that, which is what I was describing as you got to think that differently. You can't take that in a linear approach.
That's a huge customer impact. Metadata, AI, and digital twin all together. It's truly amazing. I would like to change gears a little bit again, because we've been talking about software, but there's no software without security. So could you elaborate on cybersecurity? Because obviously it always goes hand in hand.
Absolutely, and thanks for bringing that up. It actually, resiliency and cybersecurity is another one of our design principles, of course. And here we confirm for our customers that not only in the traditional ways of doing, we are cyber secure without any compromises, we also take that to the next level in the cloud. And again, metadata management is a great example here because we are the first ones to get the Star Award of the CSA, the Cloud Security Alliance, which proves that cybersecurity is not only at the core of our, let's say, traditional and proven portfolio, but also of our new releases. And that's really crucial. And on top of that, something I'm particularly proud of is we also take defense of cybersecurity to a next level and help with services to our customers. So we just opened the Critical Infrastructure Defense Center, which is the first OT cybersecurity operations center. You know that from the IT side, but here we're taking it truly to OT and help run infrastructure of our customers in a cybersecure way with our consulting team.
Oh, your consulting team. So we learned about your 2,500 employees and you elaborated on your IT and OT experts. Now you mention a consulting team. Could you give us more color on that? Obviously, for you, everything goes together.
That is very true. Our consulting team is actually, I call it sometimes the secret sauce or the icing on the cake of our software suite. Because if you think about the transformation ahead and where our customers stand, it's an extremely challenging journey ahead of everyone, and everybody is standing at a different point. So our team of roughly 200 consultants has two capabilities. The first one is they're extreme experts in power systems, so deep physics, the very complicated stuff to keep our grids running, keep them stable, and understand what it means to get closer to the limits. The other part is they know how a digital transformation journey is shaped. And this combination really makes us the trusted advisor on that transformation journey, both from a physical expansion of and layout of the grid, as well as on that data journey that everyone has ahead of them.
This really leads me to the next question. Let's talk about the culture of your business, because obviously you have the OT engineers in there that were instrumental for the huge installed base that you're leveraging. And then you have your software engineers and data scientists that start coding on top of that to truly add the unique value. You just mentioned the consulting team. On top of that, we know you reinvent yourself. It's an agile and fast-paced environment. Plenty of challenges. How do you combine all of that in one coherent business unit?
The magic actually happens when you bring together a lot of different backgrounds, a lot of different expertise. And the magic that we're creating in our team is really debating from those different standpoints and combining the deep domain know-how from, for example, the experts that I just shared about in our consulting team with state-of-the-art software people who discuss, combine, and come to entirely new ways of approaching things. And that is really what is the culture of this team. It's about innovation, it's about rethinking, it's about shaking the status quo. And I'm very happy that Siemens provides that environment for us to really build an entrepreneurial culture where an individual can make a real difference and can really lead the way individually with ingenuity, as we say. And of course, when it comes to growth, then it's all about having the right sellers with the right competence, with the right incentive systems to really make everybody participate in our success. And last but certainly not least, it's about hiring. It's about hiring the right people and bringing together that team of diverse backgrounds, diehard cloud experts, UX experts, together with, they call themselves grid nerds. and we were very successful in developing leaders from our own teams, but then also adding great leaders from the industry, from Oracle, from Aviva, from IBM, and of course, from our DI software business.
We could go on, but unfortunately we're running out of time. So let me close with a more personal question. What is your vision for your business in 3 to 5 years from now?
I want to shape the grids of the future. I want to shape grids for the 100% renewable world, grids that run in an autonomous way. And I fundamentally believe that for more speed and impact, we got to do that in a true ecosystem approach. So collectively with partners to really create the impact for the net zero future.
Dear Sabine, thank you so much for sharing your vision and for joining us today. It's truly exciting. Excellent example for technology with purpose, and we go away truly inspired seeing that there's a technology to solve the challenges that we all face together.
Thank you, Eva. It's been a pleasure. Thanks for having me.